Welcome to another IoT intro video. I'm your host Jono, and today we will talk about PWM or pulse width modulation in IoTempower. We have here our classic setup. We have the Raspberry Pi with our own network. We have an ESP8266, a Wemos D1 Mini, and this is connected to an LED and will later be connected to a piezo buzzer. So what is pulse width modulation, or PWM? Of course, our first step should be going to Wikipedia. You see a lot of graphs here. So there are basically two dominating concepts that are important to understand. I don't want to go too much in depth here. So let's look at these duty cycles that are here. So basically, pulse width modulation is a way to create an analog output signal on a digital pin. And how can we do something analog on a digital pin? So having just zeros and one is we alternate quickly between these zeros and ones, and that's what you see here. And then the duty cycle basically means how often is something 1 and how often is something 0. So 50% means it's just half. 50% it's on and 50% it's off. And so there's another important concept, which is the frequency. It's basically how often can we switch between 0 and 1. So we see here, it seems like that there are at least 4, as a resolution of 4 here in between. So if we can switch here in 100% cycle 4 times, then we had a frequency of 4 in there. So it's basically frequency means how often can in 1 second can we switch between 0 and 1. So keep just in mind, we can create some type of analog signal on the digital pin with switching quite rapidly between 0 and 1. So how do we do that in IoTempower? Start on our classic website and go to the configuration folder, or you could use SSH and do it directly on the command line in this folder. So we go in here, IoT and IoTempower. And here's our example folder. So let's just hijack an existing node for this. Also check the manual. Go to the commands. Where is pulse width modulation? Oh, it's here in PWM. And you see the command is super easy. So we can just take it here. We can give the frequency or we can't. We can also skip it. So I will just type this in. Let's edit this. Basic to have a PWM command here. On the hardware, we have wired this to D2. So I will just call this now PW1 on D2. Then we can flash it. Just want to flash it serial. And then we say yes. There we go. Rebooting now. Let's kind of go quickly back to the manual and see how we can program it. So as you see, we can set the duty cycle, but we can also set the frequency. So let's just start playing with the duty cycle and not modify the frequency. For that, we go also in this menu and do just a simple shell escape and go to IoT. And now we can send commands here. That was called PWM1 and set, and then we can send something. But let's look first how it looks. You see at the moment the LED is off. So now let's set a value between 0 and 1000. Try 500. You see it actually turns on. Do something simpler. Set just 10. And see it is less bright. So of course it is not so nice to use this, so let's use node red instead to control our LED. Let's make a new flow and take an MQTT out and also a slider. And we call this here duty cycle. And let's go from 0 to 33 and just pipe that in the right topic, which we haven't set yet, which we know 01 PWM1 set. Let's deploy this. Let's check the UI. For that, we need the URL and append UI. And here we have our duty cycle slider and some of the tests we used before. So let's try this. See if the further I move it to the right, the brighter it gets. And the further I move it to the left, the less bright it gets. And this is a classic way of controlling the brightness of an LED. Okay, so let's now connect the other PWM device, where it is becoming interesting to also use the frequency. So we should probably make sure first that it doesn't get too annoying to set the duty cycle back, and then it should not make a noise. Yes. So let's first just try to modify the duty cycle. For this, I will now move my microphone close to the source. So I will now speak in here, and now I put the microphone right in front. So you hear we mainly do something to the volume when we move things around, not actually to the tone. So let's add another slider that might be able to do something with the tone. To get not annoyed, I will disable all the other flows. So now we have both of them. So and let's now modify both of them and see how these affect the tone. So I hope that was kind of annoying enough. And now we know how to use pulse width modulation, how we use pulse width modulation, PWM. So you can control duty cycle and frequency. You can control LEDs and also buzzers with it. But you can also control motors with it, but I will show that in another short video. I hope you enjoyed this little annoying sound demonstration, and stay tuned and visit us soon again here in the IoT Empire. Ciao!